Hi, this is Matt Burns from the University of Missouri, and today we're going to talk about how to interpret progress monitoring data. Lots of schools use what's called an aim line, which I'll talk about in a minute, but when first developed, it was developed by Stan Dino at the University of Minnesota to, um, to monitor progress towards IEP goals. And I think it still does that really well. I have an issue with it though when you start thinking about interpreting data for kids getting a tier 2, tier 3 intervention. If we're going to talk about taking a kid and moving from a small group tier 2 intervention to a highly individualized, maybe one-on-one intervention, and then from that into possibly special ed, I think we have to have a different approach to interpreting the data. So let's just first by talking about what an aim line is. An aim line is you construct a graph, you graph the data, you label your axes. The horizontal axis is usually weak, and the vertical axis is usually your data, words read correctly per minute or whatever it is. You graph your baseline data, draw a vertical line to indicate the end of the baseline phase. Then you label the phase, place an X at the median baseline score. I'll show you that in a second. Place an X at the long-term goal, draw a line. It's really all you have to do. So it kind of looks like this. Not have a line separating the two phases, and that's okay. But you have a line here that you have a baseline data point. So you have three baseline data scores. This one's the median score. Okay, it's the middle of the three. It happened here. I'm going to move that over to the middle. So I'm going to get the middle median, as I call it. So I get the middle median, the moving median, and then I draw. So that's my baseline. My goal is like it's about 70 words per minute by 30 weeks. So I put a little dot right there, and I simply draw a line connecting those two. Then I collect my data and see how the data fall in relation to that particular aim line. You want them to kind of hover on the line. You get a couple that are above, a couple that are below, but kind of right around the aim line, as you see here. And we can set that long-term goal based on proficiency. So if I'm working with a third grader, fall, winter, spring, so by spring, I want the kid to be at 119 words per minute. Okay. So you can use that to set your goal and draw your aim line. And there's a couple ways to interpret the data. Now, I'm going to talk about the 3-point rule. There's some conversation, it maybe should be a 4-point rule, either way. So if we see 3 consecutive data points or 4 consecutive data points above the aim line, that means we have a good finding. We set our goal too low. We need to rethink our goal and redraw the aim line. If we see 3 consecutive data points below the aim line, that's when we have a problem. That means that the intervention we're doing is probably not working. Should probably do a different intervention. We want to see your data nice and hovered around the same line. Now, again, that's working towards an IEP goal. You've set a goal. If it's not working, you can do something different within special ed. But with an RTI framework from tier 2 to tier 3 or tier 3 to special ed, we're going to use a different framework. For example, we're going to try and address which kids are making adequate progress with supplemental or intensive instruction and which kids are not making adequate progress. We're going to try and address those 2 questions. And now aimline does that, but the problem with aimline is standard error of measure. There's 2 things wrong with it. First of which is standard error of measure. Well, both of them are standard error. Every score in the world has error in it. Every IQ test, no matter what the test is, some amount of that score is due to measurement error. And we can compute how much the error is based on the reliability and the standard deviation. So standard error of measure, just a relationship between how free the score is from error and its standard deviation of the data. And so Ted Christ and Silberglit in 2017 did a study where they looked at, and I'm just going to, for ease here, pick a couple midpoints. They looked at grade and then assessment conditions and expected reliability. So if I've got reliability in the 0.9 range, 0.9, 0.92, 0.94, I'm talking about a third grader, it's going to be somewhere between 10, 11 points. So that means the kid's score of 25 is really somewhere between 15 and 35. And you give that kid the test, 50 times, 45 of them or even higher will fall somewhere between that 15 to 35. So standard error of measure, all scores have standard error of measure. So here's a CBM score, and let's say they had 1 baseline data point and they drew an aim line like this. Well, that score of 25, it has a standard error of measure in this case because the kid's grade a little larger. So it's somewhere between, the confidence interval is somewhere from like 13 to 37 or some large number like that. So what if we look at the kid's data, did fine, right? Making good progress. And then we see 3 consecutive data points below the aim line, but it was just below, it was trending up. Team said, let's do 1 more. And then sure enough, it was great. Right. So what if that score had been at the lowest end of the confidence range? Now, I'm granted I'm making an extreme case here to make a point, but still, this score and this score Psychometrically speaking, you have the same score. They're equivalent. This kid's score could have been this. Draw that in mind, you think, wow, those data look amazing. Well, keep in mind, this score is also equivalent with this one. Again, I picked the extreme to make a point, but still. And now you look at these data and you think, wow, they would abandon that intervention weeks before. So the standard error of measure of the baseline data influenced it too much. I did a study, it came out a few years ago, we looked at does taking 3 and picking the median, does that change the reliability? Does it improve it? And it didn't. There's still the standard error of measure of one score is too high to really draw an aim line. And even when you're taking 3 with the baseline, we still see a large effect of standard error of measure. So aim line oftentimes leads to erroneous decisions. Again, if you're monitoring progress towards special ed goals, that's fine. You can have that. It's okay. But if you're going to make a resource allocation decision, like putting a kid from tier 2 to tier 3 or tier 3 to special ed, you got to have more confidence in the data. The second point is this. Again, talking standard error of measure. This is again research by Ted Christ in 2006. I'm sorry you can't see the citation very well because of the coloring. But Ted, I'm going to make it oversimplified and just cut to the chase. So TED has weeks of progress monitoring and assessment conditions and type of measures. So we just picked the middle one here, just for conversation. After 2, 3, 4, 5, whatever weeks, after 3 weeks, you'll get a slope. And that slope is the increase of how much, the rate of improvement. We talk now about rate of improvement. And a rate of improvement of 1.5 means the kid's increasing by 1.5 words per minute per week in this example. Well, Ted's research showed that the standard error of measure of that rate of improvement, the ROI, that slope, is 4.48. It's 3 times the value of the actual slope. So the standard error of measure is huge. The range is huge. So in that case, a slope of 1.5, a slope of 3.0, a slope of 4.0, a slope of negative 2.0, those are all equivalent scores. It's really not until you get about, it's able to interpret at 12 to 14 data points until you have enough data for a reliable decision. I think you can get away with a little faster, but certainly 10 data points is going to be a bare minimum. And so now let's go back to this example where we have kid making growth with 5 data points doing fine, 6, 7, 8 are below the aim line. We think, uh-oh, he's below the aim line, we got to stop our intervention. Well, the problem with that is the error of the slope for these 3 data points is 4.48 probably, or even higher or a little less. So there's a good chance that that decision based on these 3 data points is just due to measurement error. And when you do that, you're ignoring these other 5 data points. So if I'm going to make a resource allocation decision, I want to compute ROI for all of the data and use that to interpret growth. And I'll set this up like this. You put the data and the number of weeks, go to the slope function. Your independent data are the number of weeks. Your dependent score are the data, the actual scores. So let me do a different screen share for a second here. All right, so now I'm going to compute slope and show you how to do it. It's really quite simple. You've got your data here, each kid's progress monitoring data, and up here you have the number of weeks. It has to be number of weeks. If you use a date, the actual date, it'll compute slope per day, not rate of improvement by week. So convert everything to week. So here we have week. I'm going to put my function wizard here. I'm sorry, put my cursor here where I'm going to put the slope data. In fact, I'll even bold that. Put all the slope data here. I go to function wizard right here, click on slope. Now I use this a lot. So if you don't, just do this, put your cursor there and start typing the word slope and it comes up. Now remember, it asks for the dependent data first. So dependent are the actual scores. I'm just going to drag and highlight all these data. The independent are the number of weeks, the number for the weeks. So I'm going to drag these. Hit OK. And the kid's increasing by 1.98 words per minute per week. Again, to do it one more time, slope, start typing slope, oops, click here, start typing slope, comes up. Dependent is the score, so I'll put that there. Independent are the weeks, I'll put that one here. There. Click OK, see how it's all set up, B3 to K3 compared to B1 to K1. Click OK, and this kid's increasing by 3.812. Now I can drag this to get the slope for all the kids. But if you drag it, you can see it's no longer comparing it to this top row. Oops, this top row, the number of weeks. It compared this row here to K2. So you can't do that. So you have to put dollar signs in. So, whoops. So just simply put dollar signs in for the week. What you want to do is tell it every time, look back up to that top row. So that's B1 to K1. Just simply put B $1, K $1. That's all you have to do. Put your cursor there. And when you put your cursor there, it becomes a cross. Perfect. Then it's ready to be dragged. Drag it down, and you've got data for all the kids. It's that simple. You've got slope data for all the kids. And I'm going to actually slope. I'll go ahead and sort by slope. So I'm at a team meeting now. We want to look at the kids getting intervention. How are they doing? So I'm going to do custom sort. I'm going to sort by. I put my data as headers and put slope. I like to sort largest to smallest. So I put my data as headers, sort by slope. Oops. Largest to smallest. Click OK. And it's sorted. Great. So now we have a good value of ROI. And by the way, AimsWeb and others report ROI for you. But if they don't, now we have a value of ROI. And I can compute that for 5 versus 500 kids in about the same length of time. But now, is that enough growth? So to next determine is that enough growth, I'm going to look at the benchmark standards, and these are from AimsWeb, fall, winter, and spring, second grade, 55, 80, 92. Now I'm going to compute slope for those. So that will tell me the rate of growth, the rate of improvement for the typical kid in this class. In order to maintain or close the gap, they have to grow at least this amount of growth. But I can't use fall, winter, spring. So I'm going to convert that to weeks. Remember, you have to convert everything to weeks. So we collected our fall data the second week of the year. We collected our winter data 16 weeks later, so the 18th week of the year. And we collected our spring data 16 weeks after that, the 34th week of the year. And that's a pretty typical schedule. I'm going to go slope. I'll switch it to most recent now. Slope. Again, the dependent data, that's going to be the scores. The independent data is the number of weeks. See it, click OK. And it wants to see the rate of growth for these 3 data points, for these 3 standards, but proficiency standards is 1.16. So any kid not reading any kid at 1.16 or less is not doing well. I'm not sure why I sorted why this one came up here, but that's okay. So basically, we have 4 kids who are not doing well. That's it. All the rest of the kids, there's not much reason to talk about them. Although we started this intervention in the fall, and so by winter, we want to be at the winter benchmark. So within 16 weeks, we like to be at the winter benchmark. Any kids at the winter benchmark? Let's see. I don't see any. Oh yeah, there's one. There we go. So I want to see, here it is, good example. This kid is above the winter benchmark, above the next seasonal benchmark 2 out of 3 weeks. If that's the case, then we have a conversation about dismissing this kid from intervention completely. All the rest of the kids are doing well except for these 4. So we talk about this kid. Do we need to dismiss him from intervention? And if we do, we write a transition plan because he's making good growth and he's over the next seasonal benchmark. We talk about these kids. Do we need to consider a tier 2 intervention yet? Or do we do something to intensify the intervention? I'm sorry, tier 3. Or do we do something to intensify the intervention within the tier? All the rest of the kids, we just keep doing what we're doing. And that's about it. So again, we'll compute slope. We compare it to our grade level standards and compute the slope for that. And that tells us they're making sufficient growth or not. You're essentially doing this. You want your kids, you want your growth to mirror each other. So this kid is at least making as much growth as the typical kid. I'd rather see it close the gap, right? You want to see him making more growth than the typical kid. But this kid is surely an example of one that the intervention is not being very effective. Even arguably, this one is one where the intervention is not being very effective. And again, you can sort it by slope, and you can look and see which kids need support. The criterion is 1.72. We've got a handful of kids we talk about, but the rest of the kids are doing quite well. So at the end, we decide intervention effective and successful. That means the intervention's kid's making good growth and he's reached proficiency. Intervention effective and successful. When that happens, yay, we're done. The intervention's done. Write a transition plan, let the kid be done with the intervention. But the transition plan would be, we do the intervention last like maybe once a week, and we might monitor progress still once a month. But intervention effective and successful means he made a rate of growth that exceeded the peers, and he is above the next seasonal proficiency benchmark 2 out of 3 times. Intervention effective but not successful means, yeah, he's getting there. It's all those other kids making good progress, just not where needing to be yet. When that's the case, just keep on trucking. Just keep doing what you're doing. The last two suggest that change is needed. The intervention isn't working means the kid's not making sufficient growth. That's those 4 kids I talked about earlier whose slope was below 1.16. But if we don't have enough data, then we make a change within the tier. I want to see 10, 12, 14 weeks with the data. If after 6, 5, 8 weeks we see is not progressing, but we don't have enough data yet to really make that decision, we might make a change within the tier. Add an intervention, add some support, intensify it somewhat. But if the intervention after 12 weeks still don't see the rate of growth and still below where we need to be, that's when you think it's time to move from tier 2 to tier 3 or tier 3 to special ed. And this is a study we did, me, several others, Silberglit, Christ, Gibbons, and Kulan Chafin in 2016. And we looked at 3,000 kids in 2nd through 8th grade getting intervention, all below the 25th percentile in the group administered measure of reading. None were in special ed. We computed level and slope with Ames while they got academic intervention, and then looked at their reading skills with NWEA, the map. We found was some of the kids, the intervention didn't work. Either their growth was below where it needed to be, and they didn't meet benchmark standards. But some of the kids made really great growth, 589, depending on how you looked at it. I'm gonna look at this last one here, Silberglit and Gibbons, because that's basically what I just showed you. That's looking at the standard error, that's looking at the rate of growth for the typical kid by using the benchmark norms. So it's almost 700 kids did fine. They made good growth or they reached the proficiency standard. 76 kids did not. So it's a pretty good intervention, worked really well. So when we use the map, which is this is the map score, look at all this, these are mean map scores. So this is not a measure we used to determine intervention. This is just a measure independent of the intervention. We saw the kids who were duly discrepant scored significantly lower than the kids who weren't duly discrepant. So kids who identified as LD perhaps or moved into special ed demonstrated significantly lower reading skills than kids who made good progress. And we see that's an effect size of 1.12. So for years, there's been this complaint of LD identification as not identifying kids who are functionally different than kids who aren't LD. These are all kids who are below average, all kids who are struggling readers. Did the intervention, the kids that made good growth or reached standards had better reading skills than the kids who didn't, which would be identified as LD. So that is how you interpret growth within interpret growth within an RTI framework, looking at progress monitoring data. We compute our ROI, compare it to the proficiency ROI, and then determine is the intervention effective and successful, intervention effective and not successful, intervention isn't working, intervention didn't